Welcome to session 12 of PUBH 613 Designs, Concepts and Methods in Public Health Research. We're going to start with a brief review of the last session and then move on to the learning objectives for this session. The last session was about sampling, where we discussed a number of key points. First, the sample you need to address a particular public health research question depends on the question. To put it another way, the material you need depends on what you're going to do, just as in daily life. For example, for a home project, I wouldn't buy a large piece of shower curtain material and then try to make it into a shower curtain, a dress and a pair of shoes. I would need to buy something different to make the dress and the shoes. Same with epidemiology. The materials we need to do the job depend on what we want to do. If we want to describe the population, monitor its health, and conduct health surveillance, we usually need a sample that represents the population of interest. If we want to identify who's at risk of disease, we need a model that reflects the relation between our predictors and the outcome in our specific target population, so it needs to be based on the target population, the sample. A model designed to predict the risk of heart disease in men does not predict correctly in women because men have higher risk of heart disease than women. So we have different models for men and women to match the target population of men or women. If we want to find out what works, we need to have a sample that's unbiased for assessing that particular association. And as we discussed before, a population representative sample is neither necessary or sufficient for this purpose. If you think about it, a randomized control trial is usually based on a sample of volunteers who are unlikely to be population representative. But we know that well-conducted randomized control trials are the best guide to public health action. Think vitamins. Observationally, vitamin supplements were associated with a lower risk of cardiovascular disease in the general population, but not in randomized controlled trials. The vitamins likely had no benefits in the general population, probably because the observations were confounded by richer people taking vitamins and living longer, i.e. the study picked up the attributes of the person taking vitamins, not the effect of the vitamins. So randomized controlled trials show it's not necessary to have a population representative sample to get a reliable estimate of cause and effect. Equally, a population representative study of old people can be biased by the failure to recruit people who've already died because of the exposure or something else that prevents them having the outcome before recruitment. Population representative studies in old people may show that smoking and high blood pressure appear to protect against dementia. This is possible, but it's more likely that many people have died because of their smoking or high blood pressure before they get a chance to have a dementia, i.e. the population representative study is missing the already dead and thereby giving a likely biased answer. This doesn't happen in randomized control trials, because in randomized control trials the subjects are recruited then randomized, so there's no link between selection into the study and exposure. So a population representative study does not imply a correct estimate of cause and effect. So let's have a think about the questions on the next slide. Do you need a population representative study to characterize the population? For example, to obtain their mean age? What do you think? This is a descriptive type question, a surveillance question, so a population representative sample of the relevant population would really help. Do you need a population representative study for a risk prediction model? What do you think? Well, it's a risk prediction model. It's forecasting based on what happened before. It will only work well for the population for which it was designed, where it was tested and calibrated. If we want to use a risk prediction model in a new population, we have to test and recalibrate it. So we build and test a risk prediction model in a sample representative of the population where we want to do the risk predicting. Think about it. A risk prediction model for years of life remaining would need to be different for the general population and terminally ill patients. The general population, they might have 10, 20 years to live. Terminally ill patients, a year. Need to be a different model. So, do you need a population representative study for assessing cause and effect? That's what we've discussed. No, you don't. The criteria for validity are an internally valid study, no confounding and no selection bias, including no information bias. And ideally, the study then has external validity. So now in this session, we're continuing the main epidemiological methods topics and the competency in particular. And we're focusing on two main topics, measurement and screening, because they use similar concepts. For measurement, we're going to describe the attributes of valid and reliable measuring instruments, explain the strengths and limitations of different methods of measuring and validating exposures in relation to gold standards. And for screening, we're going to explain the role of screening in public health, define and apply the use of some specific terms, i.e. sensitivity, specificity, positive prediction value, and negative predictive value. So, let's get started.